Hello everyone. This video would focus on conic section, specifically on hyperbola with center at 0, 0 or at the point of origin. And this is the seventh part. In this part, we're supposed to determine the standard equation of a hyperbola given the center, given the length of the transverse axis, and the length of the conjugate axis. Before we go further, please feel free to check out the description box below for the link of the other series of topics related to hyperbola. Before we jump into this example, let's have a review on the parts, the two cases, and the equations of hyperbola. Please notice that this hyperbola is called the horizontal hyperbola because the graph, which is in red, which is the hyperbola, is touching the horizontal axis. Now, these are the parts. The first part is the center. The center is located at 0, 0 or at the point of origin. Another part is the vertex. There are two of them. We call them as vertices. Another part is the transverse axis. The transverse axis is the line that connects the two vertices passing through the center. Another part is the co vertex, and there are two of them. We call them as co vertices. Another part is the conjugate axis. This is the line connecting the two co-vertices passing through the center. The next part is the focus. There are two of them. We call them as foci. Please remember that the focus is located to the side where the hyperbola or the branch of the hyperbola opens. Another part is the latus rectum. This is the line segment with endpoints on the hyperbola, and it passes through the focus, and there are two of them for each side. The next part are the asymptotes. These are the two lines that form an X shape where the hyperbola approaches but never touches it. We call them again as asymptotes. The equation of the asymptote with a negative slope is y equals negative b over a x, while the other asymptote with a positive slope is y equals b over a x. Now, the easiest way to draw the asymptote is by drawing a rectangle covering the 4 points, the two vertices, and the two co-vertices. And the two asymptotes are actually the diagonals of these rectangles extending outward of the rectangle. So that's a trick on how to approximately draw the two asymptotes. Now let's look at some important lengths of hyperbola. The first is the distance from the center to the vertex is represented as letter A. The distance from the center to the co-vertex is represented as letter B, while the distance from the center to the focus is represented as letter C. From here, we can go ahead and say that the length of the transverse axis, that is from one vertex to the other vertex, is a formula of 2a, while the length of the conjugate axis, that is from one co-vertex to the other co-vertex, is 2b. Now, the equation that relates all these three lengths here, A, B, and C, is C squared equals A squared plus B squared. We also have another quantity called eccentricity. Eccentricity is defined as the measure of how oval the hyperbola is. And the formula for the eccentricity is C over A. Now, we remember that eccentricity for a hyperbola is always greater than 1. Now, the standard formula for a horizontal hyperbola is x squared over a squared minus y squared over b squared equals 1. Now, please notice this. Since our A is on the horizontal axis, we therefore placed it under the x squared. And since our vertex is on the horizontal axis, the x squared over a squared is positive. Now, let's look at the second case of a hyperbola, which is the vertical hyperbola. In the vertical hyperbola, we still have the same parts. And the equation of the asymptote with a negative slope is y equals negative a over bx, while the one with a positive slope is y equals a over bx. We also have these lengths in a vertical hyperbola. We also remember that the standard formula for a vertical hyperbola is y squared over a squared minus x squared over b squared equals 1. Now please notice that our vertex is on the vertical axis. That's the reason why our A is under the Y. Remember, Y means up or down. And that's the reason why the A squared is located under the y squared. Now, we also remember that our y squared over a squared is positive because this is a vertical hyperbola. So these are the parts, the two cases, and the equations of a hyperbola with center at 0, 0 or at the point of origin. Okay, going back to the problem right here, we are given the center of the hyperbola is at the point of origin or 0, 0. So I'm going to go ahead and label this as our center right here. So in this problem, we don't know where the two vertices are and where the two co vertices are. However, we're given the transverse axis, which is 10 units long and it is vertical. And we also have a conjugate axis, which is 6 units. And so if the transverse axis is vertical, this tells us that the conjugate axis is horizontal. We can actually solve for A and B. A, which is the distance from the center to the vertex, and B, which is the distance from the center to the co-vertex, using these numbers that we have right here. Now, we remember that the length of the transverse axis is actually equal to, so I'm going to go ahead and write that as TA. That's transverse axis is equal to 2A. Now, we plug the values in. We can go ahead and say that our transverse axis was 10, so I plug it in here. 10 equals 2 times our A is missing. We don't know what it is, so we're gonna go ahead and put that as A right there. So we can solve for A by dividing 2 to both sides. Divide this by 2. So then we can go ahead and say that our A is actually 5. And we also remember that the length of the conjugate axis is actually equal to 2b, and so we can solve for b from there. So this conjugate axis tells us that CA conjugate axis equals 2b. We plug the values in. The length of conjugate axis is 6, and that is equal to 2b. Dividing both sides by 2, divide this by 2. So then we go ahead and say that our B is 3. So that's the length from the center to the co-vertex. Now, looking at this numbers that we have right here, we can, since we say that our transverse axis is vertical and it's 10 units long, so we go A would be 5 units up and 5 units down to get a total distance of 10 units in length. So I'm going to go ahead and count 5 up. 1, 2, 3, 4, 5. This is our vertex. And this is our vertex also across down here. So if you counted, the distance between these two vertices would be 10, and that is actually the transverse axis. Now looking at this, since these two vertices are vertical relative to each other, we can go ahead and say that this is an example of a vertical hyperbola with center at 0, 0. So I'm going to go ahead and write that information up here. Since this is a vertical hyperbola with center at 0, 0, the general equation for a vertical hyperbola is y squared over a squared minus x squared over b squared equals 1. So we need to determine what the a and b is, and we actually have solved it over here. So I'm going to go ahead and write these values for a and b up here. So now we are going to plug this value of a into the equation for vertical hyperbola and b into this equation right here. So our equation would come out. So this is the equation for this problem that we have up there. Now we are supposed to sketch this graph. So we already have the vertex up here, and we are going to plot the co-vertices. So we remember that the distance from the center to the co-vertex is represented as letter B, and so our B is 3. So I go ahead and count 3 to the left and 3 to the right. So this is our first co-vertex, and the other co-vertex is going to sit here. That's 3 distance from the center. So that I'm going to go ahead and write the coordinates of these two vertices and the coordinates of these two co-vertices down here. Okay, from here we can go ahead and draw the central rectangle of this hyperbola. And again, this central rectangle will connect the two vertices and the two co-vertices. Okay, from here we can draw the two asymptotes. We remember that these two asymptotes would connect the two corners of this rectangle passing through the center, and we also have the other asymptote right here. So I'm going to go ahead and draw those two asymptotes. Okay, so the equation of the first asymptote with a negative slope would be y equals, remember, to get the slope of the asymptote, we go up over to the corner of the rectangle. So I go up 1, 2, 3, 4, 5. So I write 5 over negative because I'm going to the left. 1, 2, 3. So that is 5 over negative 3x. Well, the one with a positive slope would be the same thing. I go up 1, 2, 3, 4, 5. And then I go to the right 3 to get to the corner of the rectangle. And that is a positive 3 because we went to the right. And so this is y equals 5 over 3x. So that we go ahead and determine the location of the two foci. Now we remember that the location of the focus in a hyperbola is given in an equation, c squared equals a squared plus b squared, where c is the distance from the center to the focus. So I go ahead and show that work up here. Okay, since our A is 5, I plug it in. So that's 5 squared plus our B is 3. That's 3 squared. So this comes out c squared equals 25 plus 9. So c squared equals 34. We wanted the c, so we're going to square it both sides. So this comes out c is equal to plus minus square root of 34. Or roughly this is plus minus 5.83. What does it mean? So we go up, since this is an example of a vertical hyperbola, so we go up 5.83 and we go down 5.83. So this is 5.83, should be somewhere around here. So this is our first focus, and the other focus would be 5.83 down. So this is the second focus. So we can go ahead and say that the coordinates of the two foci would be, we start with this one up here. So this is, again, this is square root of 34 or plus 5.83. So we can go ahead and say that our x is 0 and that is square root of 34. Well, this this focus that we have right here is 0 and negative square root of 34. So these are the coordinates of the two foci. So we're now ready to sketch the graph. Now let's determine the eccentricity of this hyperbola. We remember that the formula for eccentricity is E equals C over A. Now, looking at this, our C is square root of 34. We just have to plug it in. So, square root of 34 over our A is 5. So, then this is the eccentricity of this hyperbola, that is square root of 34 over 5. So this is the equation for this problem that we have right there, and this is the graph of this equation. Now let's move on to the next example. At this time, I would encourage you to pause this video and try this problem out on your own, and when you're done, unpause it and check your answer. Okay, so we go over the problem here. So in this problem, we're given, again, the center is at the point of origin, or 0, 0. We're given the length of the transverse axis, which is horizontal, and the length of the conjugate axis. So from here, we can go ahead and solve for A and B. I'm going to go ahead and show that work down here. Okay, so we've determined the values for A and B. Again, our TA stands for transverse axis, while our CA stands for conjugate axis. So solving for A, our A is 6 and our B is 5. Since this is horizontal, this tells us that our vertex is located 6 distance to the left and to the right of the center. So I go ahead and count 6 to the left. So this is our first vertex. Well, the other vertex is 6 to the right. So this is the other vertex right here. Now, looking at this, we can go ahead and say that this hyperbola that we have is an example of a horizontal hyperbola, since these two vertices are horizontal with respect to each other with center at 0, 0. So I go ahead and write that information up here. Since this is an example of a horizontal hyperbola, I'm going to write the general equation of a horizontal hyperbola down here. Okay, since we already have the values for A and B, what I would do is to plug these values for A and B into this general equation for the horizontal hyperbola. So the equation that we have for this problem right here is x squared over 36 minus y squared over 25 equals 1. Now again, we have solved the values for A and B. I'm going to go ahead and write that up here. Since we have a value of B, and that is where our co-vertex is going to sit from the center, so I count 5 up and 5 down, and that would be the location of the two co-vertices. So this is our first co-vertex, and this is the second co-vertex right here. So I'm going to go ahead and write the coordinates of the two vertices and the coordinate of the two co-vertices down here. Okay, so then we go ahead and draw the central rectangle and the two asymptote for this hyperbola. Okay, so I've drawn the central rectangle and the two asymptotes. So the equation for the asymptote with negative slope would be, remember from the center, we go up to the corner of the rectangle. So we went up 1, 2, 3, 4, 5, and we went to the left 1, 2, 3, 4, 5, 6. So that is y equals 5 over negative 6x. Well, the other one right here, we go up 5 and right 6. So that is y equals 5 over 6x. So we go ahead and determine the location of the two foci. We remember that the location of the focus is c distance from the center. So we can go ahead and use the equation c squared equals a squared plus b squared to get the value for the c. So I'm going to go ahead and show that work up here. So the two foci will be located 7.81 steps to the left and 7.81 steps to the right. So I'm going to go ahead and plot those two foci and determine its coordinates. Okay, so the two foci are located. So this one right here is negative square root of 61, 0, or that is negative 7.81. These are both positive and negative, and then 0, and this one right here is square root of 61 and 0. So I go ahead and sketch the hyperbola. Okay, so then from here, we go ahead and determine the eccentricity of this hyperbola. We remember that the formula for eccentricity is E equals C over A. Our C is square root of 61 and our A is 6. So the eccentricity of this hyperbola is square root of 61 over 6. Did you get the same answers as this? Good. Perfect. If you found this video helpful, hit like and subscribe for more math videos. See ya!